Hi everyone, welcome back to my channel Vertex Manoj Roy. Sets is one of the important topic in O-levels mathematics, add maths, or even all types of mathematics. So let's start. This video is especially for those students who are like starting sets first time. So let's see. Basically, sets, if we define a set, is called a collection of data, a collection of facts, or a collection of something. It can be anything. For example, normally we write set with capital alphabet equals to and this curly bracket. So I can write here one example like set of numbers which are divided by 2. I'm not using this word even number. Even I can say, okay, set of even numbers. Set of even numbers 2, 4, 6, 8, 10, and so on. And bracket close. This is a normal set. The set can be like we can say the set of quadrilaterals. So quadrilaterals we can say with Q we can use alphabet. In quadrilaterals we have a rectangle, a square, rhombus, rhombus and kite. Like so many things we can make the set. There are so many figure. We can have like quadrilaterals or if you're talking about triangles, so you can say obtuse angle triangle. Like we have so many types. You can write like set of polygons. So polygons means in polygons we have a triangle, we have a square, we have a pentagon, hexagon, heptagon. There are so many things. This is the set. Sets category can be changed according to the level of exam. For example, if you are the student of normal maths, so you will not be having the questions about the trigonometrical ratios. Like if you have admas, like in admas we have to write like a is equals to, we have a question like this, sine theta is equals to, for example, 270 degrees, and they asked to find the set of theta. So this depends upon the given question. That's what level of topic you have in the examination. Like in ADMAS, we have like trigonometry in the sets. We have about integration, differentiation, kinematics. All things are possible that can come in sets. So we should know this what is the boundary of our syllabus. So sets can come in any of the topic. So finite set, this is the finite set means when we have like we can say English alphabet. So English alphabets, if you write A and this A, B, C, D, and and et set. So we have altogether 26 elements. Okay. This like A, B, these are called the elements. We can say the elements or we even say the members. Like all these elements, all our members. And the finite set means we have the sets which have the particular numbers. For example, or in English alphabets, we are having like about 26 alphabets. So I can write one thing, N, A. And A means how many number of elements are there in this set A. So there are 26. So this is also very important. N means like if you're talking about this one, the set of even number. So what is the set of even number? If I write here, suppose E. Set of even numbers, can you count for how many even numbers? So this even number when you cannot count because it's infinity, so it means this is called the infinite set and this is called the finite set when we have a particular number of like members or the elements. So what we have this in this picture, that's we are having the elements, the members, this sign equal to, and this bracket is very important for the set. I would like to increase something about this how we represent a set actually. There are so many ways in different types of mathematics, but I would like to explain these three like representation of the sets. The first is listing. Listing means when this is the normal, you have already seen this A is equals to English alphabet. I'm writing first four alphabets. So A, B, C, D. So there are four members. This bracket, this is called the listing when we write with the comma. This is very simple. Second is build-in notation. Build-in notation is most important part in additional maths or the university level. This is very important. We have like if I write, for example, I want to write the natural number and the natural numbers. I want to write 1, 2 till 10. And please remember what are the natural numbers, what are the whole numbers, what is the difference between the natural number, whole number, even number, odd numbers, or the prime numbers. I will be explaining after this like sometime. This is the same video. So natural number I am writing here, for example, n is curly bracket equal to, and I'm writing here x this sign, then again x, no, this sign x, and this sign epsilon, and suppose here I write, and I change this, not E, I'm writing here suppose B. B is here, and I'm writing something like this, and you have to, how we read this, I want to explain you. Okay. X such that X is a member of natural number. This means this is such that. Okay, this is such that. So how we read X such that X is a member. E is the element or the member. You can write the element or the part of or the member. X such that X is a member of natural number. Natural numbers are there. And X is less than equals to 10 means we have to make the list. And how we can make the list here? If I move up, I can make the list of B part here. Listing that B is equals to, this is the one thing is given, X is less than equal to 10. But we are not sure how we start. You know the natural number always start from 1. So this is the list of the natural number from 1 till 10. We have done listing, build notation, and the common notation is also called the descriptive form. Sometimes they ask, and how we represent here, I would like to write here B is equals to curly bracket. We write here, and we write X. This we write colon here, not semicolon, it's colon, double dots, and X is less than equals to 10, and we write here in like comma here, and we write X is a natural number. So this is called actually a descriptive form, and we hardly have this situation, but sometimes we have. So we should know. The most important is this one. This one, and normally this is the common, like we use the listing method. So there are three ways I explained you the, how we represent set. Okay, some important sets I would like to explain you the whole numbers, natural numbers, even numbers, odd numbers, prime numbers. This is very important. It's also useful for like our maths or add maths. So whole numbers we normally represent with W. I'm writing here whole numbers. What are the whole numbers? Whole number always start from 0. This is very important. 1, 2, 3, and so on. So it's infinite set here because we do not have the limit here for the whole numbers. Natural numbers are the numbers start from not 0, start from 1. This is most important part because sometimes we have to give the answers. That's the x, we have to find x, and x is a member of natural numbers. So please do not write 0. Even numbers are the numbers is like very common to multiple of 2, 2, 4, 6, 8, 10, and so on. Then we have the odd numbers. Odd numbers are those numbers which are not even numbers like 1, 3, 5, 7, 9, and so on. Then we have a prime number. Prime numbers are the number which are divided by itself or 1. Or we can say the factors of the numbers are only 2, 1 or itself. So without 1, 2, 3, not 4, not 5. Yes, 5 is a prime number. 6, 7 is a prime number. 8, 9, 10, 11 is a prime number, 13 is a prime number, 17 is a prime number, and these number are not come does not do not come in other tables, so it's a prime number. Integers, like what are integers? Basically, integers mean set. We write z, and integers means it can be plus integer, it can be whole integers. So integers basically we write -3, -2, -1, 0, 1, 2, 3, and so on. So normally we can write the integers are 0 plus -1 plus -2 plus -3 and so on. So these are the integers and we have to use like in all types of mathematics. So moving to the types of sets, we have empty sets means when a set A having no member, or we can write this sign. Please note, please do not write like this that A is equals to this and this. This is wrong. Only this one or this one. This is called the empty set or the null set. Disjoint sets or equal sets are reciprocal to each other. I mean, disjoint set means if A is 2, 3, 5 and B is PQR. So it means this are like we can say disjoint set, not equal, and this equal means if A is 1, 2, 3, B is also 1, 2, 3. This is the equal set. This is most important, but I want to discuss the subset. Subset, normally what we write A is equals to, for example, uh, A, B, C, and D. And I write B is equals to A, B, C, and D. And if I take one more element, more set, C is A, B, and maybe D. What do you observe? A and B are called the subset. So what we write, A is a subset of B. When all the elements are equal, or even you can say the equal set is a subset. But the proper subset is what the C is a subset of A, or C is also a subset of B. So what is the difference actually the subset and the proper subset? Sorry, the proper subset. The proper subset have something, one of the missing element. Not all the members are same elements. Like in C, A, B, D, and in A we have A, B, C, D. So when we're talking about A and B, it's called the subset. But when we're talking about A and C, C is a part of A, so it means C is a proper subset of A, and C is also the proper subset of B. So this was the common explanation. I said just one more thing I want to discuss about the universal set. I have some example here I would like to use from the ADMAS exercise 1.1b. For example, before that, I would like to say what is a universal set actually. Universal set normally in international language, we write this sign, epsilon. And universal set is called the father set, also called the father set. It means all sets are the part of that father set. And in national language, like level, we write the universal set with this U. Like in when we are have the exam nationwide, so we have U for the universal set. But for the international examination, we have epsilon, the sign. Okay. For example, this we can see here. This sign is given here. This sign is epsilon. You can see epsilon and 1, 2, 3, 4 till 10. It means all the sets will be the part of this. It means we cannot exceed from this boundary 1 till 10. We cannot. This is the main, like this, the father set of this question, this particular question number 1. Okay, let's see. Given, I want to list the elements. You know, the listing means we have to write all the elements. Let's see. Set A, I will write with a comma. Listing. X is colon 5x. Okay, what we have to do here, first of all, we have to simplify this. Actually, this is the meaningful thing. This is very important. Okay, when I find the value of x, is 37 divided by 5. So it's coming about 7 point something. We can write 7 point, or I do not know 7 point. Okay, it's 2, 7.2 means 7.4. Okay, I think so. Yeah. So it means this is greater than. So whenever this situation is arise, like what we have to write all the members in the set A which are greater than 7.4 or 7 point something. So it means 7 is not involved. So what I will write 8, 9, 10. So I will write only these three numbers 8, 9, and 10 because the limit of the father set, the universal set is fixed. 1 till 10. I cannot write less than 1 or more than 10. So that's the A part. When you see B part, in B part we have to just think about this part, this equation. We have to simplify this. X plus 5 less than 12 and x is 12 minus 5 is 7. Okay, so this is not equal to, this is only 7 means I'm talking about, not 7 means I'm talking about this set. So what's the like listing for B? How many list of elements we can write? We can 1, 2, 3, 4, 5, and 6, not 7, because this is not equal to. When we have equal to, then we can write till 7. Maybe you will understand after a few videos of the sets. So this part, see, you can see only this one, not this, only this one, only this part. Okay, 6. This is one part of inequality. So what we do here, we write in two inequalities normally. So what we write, 6 is less than 2x. To divide here, 3 is less than x means x is open mouth toward x means x is greater than 3. And when we're talking about this one, x is like 8.5, like 16 divided by 2, something 8.5. So we have two things now. X is greater than 3 means x is greater than 3, not equal to. So 4, 5, and this here we can see 8 till 8.5 means this here, till here. So what we write, x is, like, sorry, the element is c. C is equals to 4, 5, 6, 7, and 8. This is the most like the way we have done. In D part, when you see D is x squared, I'm just solving it, x squared less than 37. So I can do one thing when I make the square root, like square root of 37 is near to 36. And so my answer will be definitely 6 point something. I do not like 6.1 or 6.0 something. 6.1. Okay, I'm writing 6.1, but this is like 6 point something. So it means your result of like should be not like till 6 and less. So your right answer is D is equals to like D part, that listing are 1, 2, 3, 4, 5, and 6. I can also move to question number 2, but I don't want to make my video lengthy actually. Let's see, this is like I told you, integers, all positive, negative. So, but here is fixed, the elements are from 1 to 20. The universal set or the father set is from 1, 2, 3 till 20. So it means I cannot I cannot write the elements less than to 1 or more than 20. This is my boundary for this particular question. If I write like we had to write a list of all the elements, so A is here, like A is you can see x is a multiple of 2. So multiple of 2 means I will write 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. I will not write more than 20 because the boundary of the father set or the universal set is fixed. So it's very important. B part. B is what? The B is given here that x is a multiple of 5. So it means I will write 5, 10, 15, 20, and so on, because I cannot write more than 20. Next is x is a multiple of 10, means I can write the c is equal to 10 and 20. And that's like we have done. Uh, State whether each of the following is true or false. Okay, C is a like, remember I discussed with you, this is the proper subset, means C should have not all the elements of A. So C, 10 and 4. So if it's right, I will use green color. Okay. So C is a proper subset of A. Yes, absolutely. Because the 10 and 20 is a part of A. So it means it's true. If I move to second part, if true, I will use green color, otherwise the other color like I will use. B is a proper subset of A. 5, 10, 15 is not there. Like 15 is not in A. So I use different color to show that this is false. This is uh, false. Actually, I use sometimes false is a German word. So because I also speak German, so that's why sometimes falsch and war and falsch. So next is C is a proper subset of B. C is a proper subset of B. Yes, that's right. So I use this color. So by this way, we have done question number 2. I think so. Starting of the set is enough here. Like this, okay, and I'll be continue with like question number 3 onward, same exercise. If you think this video is useful for you, like you, please share with your friends. And I really like your comments when you ask something just to make some video about the topic on the topic. Thank you so much for your feedback and have a nice day.